Hello, everybody. All right, we are going to do this worksheet, Simple Machines. This will be the video for questions 1 through 3 on our Simple Machines worksheet. All right, so the first thing we need to do, we are given a 50-pound resistance force and a 15-pound effort force. We are also given 4 feet for our effort distance. All right, so first thing we need to do is draw out our picture. So we're going to do a first class lever here. So here's my first class lever. I don't really need to have it to scale. Some other people might want to have it to scale. And we are going to I'm going to get this a little bit smaller here. So we're going to have on one distance here, we're going to be putting our effort distance. All right, so that's our DE, or an effort force too. All right, and then over here is going to be our resistance. Okay, remember that the resistance is what ends up getting lifted. The effort is what we have to put into it. Okay, so we know that we have 50 pounds of force that's going to be sitting down here. So we have a 50 here, 50 pounds. Okay, and we have 15 that's going to have to be pushed down here. 15 pounds there. All right. Sorry, got a little big with the letters. Now, so that's the general idea. And we also know that we're going to have 4 feet from the fulcrum. Here's our fulcrum. So we have 4 feet that's going to be going from the fulcrum to our effort. So we're going to have this distance here. That is 4 feet. All right. And we're going to need to figure out what our resistance distance is going to be. Okay. So question number 2 says, what is the actual mechanical advantage AMA? So I have am I free? Am I free? AMA is going to be equal to the resistance force divided by the effort force. Am I free? All right. So we have our resistance force is going to be 50 pounds. So we have 50 pounds divided by our effort force, which is 15 pounds. All right. We divide that out and we get our AMA is equal to 3.33 repeating. Okay. So there you go. No units on it because it's a ratio. We shouldn't have units. The pounds, as you should see here, the pounds should have canceled out. All right. Okay. Now, using static equilibrium calculations. And it also mentions at the beginning of the worksheet that you should assume that there's no friction loss. So we can say that the AMA, all right, AMA is equal to the IMA, all right? Or more specifically, we can put in our whole equation for it, which means we're going to have the equation for AMA, resistance force over effort force, is equal to my IMA, which is going to be I'm a deer. All right, so I'm a deer. Oops, that's ugly, but I'm a deer is going to be IMA is equal to DE over DR. Okay, so we have our effort distance divided by our resistance distance, which is just fun to say. Okay, so we have those two equal to each other. Then we can substitute it in. So we have our FR is 50 again. Our FE was 15. That's going to be equal to our effort distance. And our effort distance up here we said was 4 divided by our resistance distance. Whoops, our resistance distance there. Okay, so we do our cross multiplication here to solve for the right answer. So we're going to do 4 times 15 and 50 times dr. I'm going to go over here do so 50 times our resistance distance is equal to 4 times 15, which I can do in my head is 60. All right. So now we divide both sides. Whoops. Divide both sides by 50. Yoink, yoink. 50s go away. The resistance distance is going to be 60 divided by 50, or 1.2. All right. We're measuring force. Okay, I'm sorry. No, we're measuring length. So It's going to be 1.2 feet. And there is your answer.